Welcome to Reality Creative Video. I'm Hermes, and it's been a little while since I did a video, so I'm just going to cover what's been going on here in this week. Now, first, platinum. I'm not happy with my platinum formula. Sometimes it gets me between 1 and 3 parts per million most of the time. I mean, sometimes I have to throw batches out because it doesn't give me any platinum. And I know I posted the formula, it does work most of the time, but it's just not consistent enough for me. So I am working on a different way. So right here I have colloidal platinum cooking. Instead of using Manuka honey, I've used absorbic acid. And I've taken out the vanilla flavoring, the alcohol from it. It still has the gold formula stuff sitting in there. I think the main problem I have with platinum is the platinum dioxide. It forms on the cathode, and once it forms on the cathode, I can't seem to get any more platinum off of it. So I found out that if I'm still testing it, I can't say it's 100%, all right? But I found out that if I use 2 platinum rods, and I take the platinum rod that is the anode, if it's got platinum dioxide on it, it gets burned off or removed. I don't know what happens with it because it never loses any weight, but anyway, it gets removed. And so what I'm doing now is every hour I am swapping the anode and the cathode. So when the platinum builds up, takes about an hour, builds up on the cathode, I take it and put it on the anode. I take the anode, which is now clean, and I put that on the cathode. And so I want to see if that helps me to get past my 2 parts per million bottleneck, or, at least gives me consistency with the fluid working. And I like absorbic acid because it's not as syrupy. Not that the colloidal actually tastes very nice with all the syrup in, but I would prefer not to have to cook my colloidal with heavy syrup because A, the Manuka honey is loaded with colloidals. And that's probably what makes the honey, so beneficial for you, because this stuff is saturated with colloidals. But that doesn't make it easier for me to tell if I got platinum in the solution or I got just the mess of honey in the solution, especially with the weight on the rods coming down at such a small amount each time. It's like when I cook gold or something else. I mean, we got like 7 milligrams of material coming off. I mean, the scale can easily measure that. But when you only got 1 or 2 milligrams coming off, if you're lucky, the scale has a really hard time measuring it. So the only other way that I know that if I got colloidals is to throw it in the microscope. Now, if I got a whole bunch of Manuka honey colloidals sitting in there, I can't tell the difference between whether I got colloidal platinum in there or a bunch of Manuka honey stuff going on. So that's one experiment that I'm working on. The other experiment is the high voltage AC colloidal maker. Now I showed you the picture of that transformer I purchased, and I went to test that transformer last week and it didn't work. So I sent that transformer back and I purchased a different transformer, which looks like it comes from the same company, but the design is a little bit different. And that transformer works. So yesterday, for the heck of it, I set up a rig. Very fast rig here. I used a plastic beaker because I wasn't sure what was going to happen with glass or anything like that in high voltage AC going on. And so what happened was I used silver rods, and what happened was I had the one silver rod turned completely black. But when I put it in the microscope, there was no silver in the liquid. So it was like I was able to liquefy the silver, but it didn't create any colloidals. So what I need to do is stir it. I'm pretty sure the problem is I'm not stirring the fluid, so it's just sitting there and it's not going off and circulating in the thing to create the colloidal. So I grabbed my old, thank goodness anyway, I grabbed my old stirrer, that battleship brown color stirrer that I first used before I got this really nice one. I brought that out and I set that up. And by mistake, I put the high voltage transformer too close to the stirrer, and the stirrer is magnetic, and I burned out. Somehow the magnetic field of the high voltage transformer interfaced with the magnetic field of the stirrer and burned out the stirring circuit. Thank goodness it was a cheap stirrer. But that brings up one of the dangers of high voltage AC. You can't put it near any of your equipment. So I'm going to need to set up a special rig, on the other side of the lab, and I've ordered a new stirrer, one of these cheap stirrers. I'll try and keep the transformer far away from that stirrer as possible this time. And I'm going to try the stirrer, see if I can get the stirring going and maybe get some colloidals out of it, because right now I didn't have any colloidals in the solution at all from the high voltage AC. So, but basically the high voltage AC is the same. I mean, you just have you have to have two of the same material, anode and cathode, because it's AC, so you're going to be swapping the stuff off of each of the things. So basically, I would have an anode and a cathode of the same thing, in this case silver, and then instead of having a low voltage power supply, I'll be hooking 10,000 volts up to it, within the liquid. It's pretty much similar to our, how we do a low voltage electrolysis, except we're using 10,000 volt transformer. So I worked on that. I don't have video from it. I'm sorry. It was just like a quick, let's try it and see what happens sort of thing. But hopefully I'll get my stirrer and I can, maybe shoot some video on that and show you guys just a small setup, which is very crude, that I'll have going there with the high voltage AC. So thank you very much, everybody, for visiting and taking the time to watch my circus that goes on over here. I enjoy sharing all these things with you. I'm Hermes. This is Reality Creative Video, and I will talk to you again soon.